All right, guys, moving on. We're going to do, for a video lesson today, the Rational Zero Theorem. And hopefully you did see this last year. Everything we've been doing has been based off of finding the zeros, all right, or finding all the factors. And we've been able to do that by sometimes they give us the factor, and then we use synthetic division, or sometimes they give us the graph and we see where it hits the x-intercept. So they kind of give us a hint. But what if they didn't give us any hint at all? This is where we would have to use this rational zero theorem. And it looks really complex, but it's really not. Like when you look at this, it's kind of like, what is that? Um, this is the main thing that you have to know. I have x equals plus or minus p over q. These are the possible rational zeros. All right. And what that means is p is saying it's all factors of the constant, which is this a sub 0. Right? When you list a polynomial out and you list it with the highest exponent, like x to the third plus 3x squared plus 5x plus 2, 2 is this constant. And its only factors would be 1 and 2. This q is all the factors of the leading coefficient, which in this notation is a sub n, it's this. Okay, so if I had, let's say, I had 4x squared plus 2x plus 1. 4 would be the leading coefficient, and all its factors would be 1, 2, and 4. All right. Here, guys, this is a classic example of trying to make this a lot harder than it is. When we put numbers into it, it's going to make it a lot easier. So what this is telling us is when we get this list, these are the possible rational zeros. And then once we have that list, then we can use synthetic division to see which one gives us a remainder of 0. All right, let's go down to number 1. Let's see. Okay, move it up. All right. Focus in here on number 1. All right, here we go. So when it says plus or minus p over q, all right, I'm going to put x equals plus or minus. So p, remember, these are all the factors of the constant, which is just 2. Well, that's really easy because 2 is a prime number, so it's just 1 and 2. So I'm going to put 1 and 2. And then the bottom right here, I get all the factors for the constant, which should be the last term, which is 8. And all the factors for 8 are 1, 2 times 4, and then 8 itself. All right, now I'll use a different color. This is how we come up with the list of possible rational zeros. All right, I'm going to take this, I'm going to divide it by every single one of these. So 1 over 1 is just 1. 1 over 2 is a half, and I'll put plus or minus 1/2 because that's what the theorem states. 1 over 4, I just have plus or minus 1/4. And then 1 over 8 is just plus or minus 1/8. Okay, then, all right, I'm done this. Then I take the 2 and I divide it by everything here. So 2 over 1 is just 2, so I'm going to put plus or minus 2. 2 over 2 is 1, but I already have that on the list. 2 over 4 is 1/2, I already have that on the list. And 2 over 8 simplifies to 1/4, I already have that on the list. So this right here, if you look, we got 1, 2, 3, 4, 5, but it's plus or minus for each. So you double it. So this is 10 possibilities. All right, 10 possibilities. All right. So what that means is after I get this list, I'm only going to use synthetic division for these numbers listed. And then it's just trial and error. All right, let's do number 2. All right, so number 2, it's in blue. So we're going to put x equals plus or minus. And then remember the top, those are the factors of the constant. Well, the one thing actually is a little tricky here, and I was almost going to start writing them down. This actually is out of order. It's not in standard form. This actually is the leading coefficient. So I would want to move this all the way to the front. So it's 3x. Okay, so I'm going to put the 3x cubed out front. So it's 3x cubed plus 4x squared minus 3x minus 12. All right, you don't want to fall for that. I almost did right there. Okay, so make sure it's in standard form. You start with your highest exponent, then you go to your constant. So it said the top are all the factors for the constant, which is 12. So we kind of have some possibilities here. We got 1, 2, 3, 4, 6, and 12. These are all the numbers that go into 12. And then the bottom are all the factors for the leading coefficient, which looked like it was this, but it was actually this, the 3x cubed. So that's just 1 and 3. All right, looks like this is going to have a little bit more possibilities. All right, so let's use the green. So if I take the 1 over this one is 1, and then 1 over 3 is just 1/3, so it's plus or minus 1/3. Then we'll take the 2 over 1 is plus or minus 2. 2 over 3 is plus or minus 2/3. Then we do the 3. 3 over 1 is plus or minus 3. 3 over this 3 is 1, which we already have. Okay, so then we do 4. 4 over 1, it's not on the list yet, so it's just plus or minus 4. 4 over 3, so we have plus or minus 4/3. We have a lot of possibilities for this. Okay, then 6 over 1 is just plus or minus 6. And then 6 over 3 is 2. I already have that on the list. Then we take 12. 12 over 1 is just 12, so it's plus or minus 12. And then 12 over 3 is 4. That's already on the list. This, you have a ton of possibilities. Let's count. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. You double it because you have plus or minus. So there's 18 possibilities for this. Just abbreviate that. 18 possibilities. You're going to see, guys, for these ones, if I don't allow you to use the graphing calculator, I'm not going to give you ones like these where you would have to do synthetic division like 10, 15 times to find the zeros. If I were to give you this problem like number 2, I would probably let you use your graphing calculator to find the zeros first and then use synthetic division. All right. All right, so plus or minus P over Q, this just gives you the possible rational zeros. It gives you a list for them, and then whatever's on that list, you can start taking the numbers that are on that list and start using synthetic division for it.